The Lockheed C-5 Galaxy is a large military transport aircraft built by Lockheed. It provides the United States Air Force with a heavy intercontinental-range strategic airlift capability, one that can carry outsize and oversize cargoes, including all air-certifiable cargo. The Galaxy has many similarities to its smaller C-141 Starlifter predecessor, and the later C-17 Globemaster. The C-5 is among the largest military aircraft in the world. The C-5 Galaxy had a complicated development. Significant cost overruns were experienced and Lockheed suffered significant financial difficulties. Shortly after entering service, fractures in the wings of many aircraft were discovered and the C-5 fleet were restricted in capability until corrective work was conducted. The C-5M Super Galaxy is an upgraded version with new engines and modernized avionics designed to extend its service life beyond 2040. The C-5 Galaxy has been operated by USAF since 1969. In that time, it has been used to support U.S. military operations in all major conflicts including Vietnam, Iraq, Yugoslavia and Afghanistan, as well as in support of allies, such as Israel during the Yom Kippur War and NATO operations in the Gulf War. The C-5 has also been used to distribute humanitarian aid and disaster relief, and support the U.S. Space Shuttle program run by NASA. Development, CXX and Heavy Logistics System. In 1961, several aircraft companies began studying heavy jet transport designs that would replace the Douglas C-133 Cargomaster and complement Lockheed C-141 Starlifters. In addition to higher overall performance, the United States Army wanted a transport aircraft with a larger cargo bay than the C-141, whose interior was too small to carry a variety of their outsized equipment. These studies led to the CX-4 design concept, but in 1962 the proposed six-engine design was rejected, because it was not viewed as a significant advance over the C-141. By late 1963, the next conceptual design was named CXX. It was equipped with 4 engines, instead of 6 engines in the earlier CX-4 concept. The CXX had a gross weight of 550,000 pounds, a maximum payload of 180,000 lb and a speed of Mach 0.75. The cargo compartment was 17.2 ft wide by 13.5 feet high and 100 ft long with front and rear access doors. To provide required power and range with only 4 engines required a new engine with dramatically improved fuel efficiency. The criteria were finalized and an official request for proposal was issued in April 1964 for the Heavy Logistics System. In May 1964, proposals for aircraft were received from Boeing, Douglas, General Dynamics, Lockheed, and Martin Marietta. General Electric, Curtiss-Wright, and Pratt & Whitney submitted proposals for the engines. After a down select, Boeing, Douglas and Lockheed were given 1-year study contracts for the airframe, along with General Electric and Pratt & Whitney for the engines. All 3 of the designs shared a number of features. All 3 placed the cockpit well above the cargo area to allow for cargo loading through a nose door. The Boeing and Douglas designs used a pod on the top of the fuselage containing the cockpit, while the Lockheed design extended the cockpit profile down the length of the fuselage, giving it an egg-shaped cross-section. All of the designs had swept wings, as well as front and rear cargo doors allowing simultaneous loading and unloading. Lockheed's design featured a T-tail, while the designs by Boeing and Douglas had conventional tails. The Air Force considered Boeing's design better than that of Lockheed, although Lockheed's proposal was the lowest total cost bid. Lockheed was selected the winner in September 1965, then awarded a contract in December 1965. General Electric's TF-39 engine was selected in August 1965 to power the new transport plane. At the time GE's engine concept was revolutionary, as all engines beforehand had a bypass ratio of less than 2:1, while the TF-39 promised and would achieve a ratio of 8:1, which had the benefits of increased engine thrust and lower fuel consumption. Into production. The first C-5A Galaxy was rolled out of the manufacturing plant in Marietta, Georgia, on March 2, 1968. On June 30, 1968, flight testing of the C-5A began with the first flight, flown by Leo Sullivan, with the call sign 8303 Heavy. Flight tests revealed that the aircraft exhibited a higher drag divergence Mach number than predicted by wind tunnel data. The maximum lift coefficient measured in flight with the flaps deflected 40° was higher than predicted, but was lower than predicted with the flaps deflected 25° and with the flaps retracted. Aircraft weight was a serious issue during design and development. At the time of the first flight, the weight was below the guaranteed weight, but by the time of the delivery of the ninth aircraft, had exceeded guarantees. In July 1969, during a fuselage ovending test, the wing failed at 128% of limit load, which is below the requirement that it sustain 150% of limit load. Changes were made to the wing, but in a later test, in July 1970, it failed at 125% of limit load. A passive load reduction system, involving uprigged ailerons, was incorporated, but the maximum allowable payload was reduced from 220,000 pounds to 190,000 pounds. At the time, it was predicted that there was a 90% probability that no more than 10% of the fleet of 79 airframes would reach their fatigue life of 19,000 hours without cracking of the wing. Cost overruns and technical problems of the C-5A were the subject of a congressional investigation in 1968 and 1969. The C-5 program has the dubious distinction of being the first development program with a $1 billion overrun. Due to the C-5's troubled development, the Department of Defense abandoned total package procurement. In 1969, Henry Durham raised concerns about the C-5 production process with Lockheed, his employer. Subsequently, Durham was transferred and subjected to abuse until he resigned. The Government Accountability Office substantiated some of his charges against Lockheed. Later, the American Ethical Union honored Durham with the Elliott Black Award. Upon completion of testing in December 1969, the first C-5A was transferred to the Transitional Training Unit at Altus Air Force Base, Oklahoma. Lockheed delivered the first operational Galaxy to the 437th Airlift Wing, Charleston Air Force Base, SC, in June 1970. Due to higher-than-expected development costs, in 1970 there were public calls for the government to split the substantial losses that Lockheed were experiencing. Production was nearly brought to a halt in 1971 due to Lockheed going through financial difficulties, partly down to the C-5 Galaxy's development but also a civilian jetliner, the Lockheed L-1011. The U.S. government gave loans to Lockheed to keep the company operational. In the early 1970s, NASA considered the C-5 for the shuttle carrier aircraft role, to transport the Space Shuttle to Kennedy Space Center. However, they rejected it in favor of the Boeing 747, in part due to the 747's low-wing design. In contrast, the Soviet Union chose to transport its shuttles using the high-winged An-225, which derives from the An-124, which is similar in design and function to the C-5. During static and fatigue testing, cracks were noticed in the wings of several aircraft, and as a consequence the C-5A fleet was restricted to 80% of maximum design loads. To reduce wing loading, load alleviation systems were added to the aircraft. By 1980, payloads were restricted to as low as 50,000 lb for general cargo during peacetime operations. A $1.5 billion program, known as HMOD, to re-wing the 76 completed C-5s to restore full payload capability and service life began in 1976. After design and testing of the new wing design, the C-5s received their new wings from 1980 to 1987. During 1976, numerous cracks were also found in the fuselage along the upper fuselage on the centerline, after the refueling port, extending back to the wing. The cracks required a redesign to the hydraulic system for the visor, the front cargo entry point. Continued production and development. In 1974, Iran, then holding good relations with the United States, offered $160 million to restart C-5 production to enable Iran to purchase aircraft for their own air force. in a similar climate as to their acquisition of F-14 Tomcat fighters. However, no C-5 aircraft were ever ordered by Iran, as the prospect was firmly halted by the Iranian Revolution in 1979. As part of President Ronald Reagan's military policy, funding was made available for expansion of the USAF's airlift capability. With the C-17 program still some years from completion, Congress approved funding for a new version of the C-5, the C-5B, in July 1982 to expand airlift capacity. The first C-5B was delivered to Altus Air Force Base in January 1986. In April 1989, the last of 50 C-5B aircraft was added to the 77 C-5s in the Air Force's airlift force structure. The C-5B includes all C-5A improvements and numerous additional system modifications to improve reliability and maintainability. In 1998, the avionics modernization program began upgrading the C-5's avionics to include a glass cockpit, navigation equipment, and a new autopilot system. Another part of the C-5 modernization effort is the reliability enhancement and re-engining program. The program will mainly replace the engines with newer, more powerful ones. 3 C-5s underwent RERP as a test with full production in May 2008. A total of 52 C-5s are contracted to be modernized, consisting of 49 B, 2C and 1A model aircraft through the Reliability Enhancement and Re-engining Program. Over 70 changes and upgrades are incorporated in the program, including the newer General Electric engines. 5 C-5M Super Galaxies have been produced. The RERP upgrade program is to be completed in 2016. Design overview: the C-5 is a large high-wing cargo aircraft. It has a distinctive high T-tail, 25-degree wing sweep, and 4 F-39 turbofan engines mounted on pylons beneath the wings. The C-5 is similar in layout to its smaller predecessor, the C-141 Starlifter. The C-5 has 12 internal wing tanks and is equipped for aerial refueling. It has both nose and aft doors for drive-through loading and unloading of cargo. The C-5 is also known as FRED by its crews due to its maintenance reliability issues and large consumption of fuel. It is an upper deck seating area for 73 passengers and 2 loadmasters. The passengers face the rear of the aircraft, rather than forward. Its takeoff and landing distances, at maximum gross weight, are 8,300 ft and 4,900 ft respectively. Its high flotation main landing gear has 28 wheels to share the weight. The rear main landing gear is steerable for a smaller turning radius and it rotates 90 degrees horizontally before it is retracted after takeoff. The kneeling landing gear system permits lowering of the parked aircraft so the cargo floor is at truck bed height to facilitate vehicle loading and unloading. The C-5 has a malfunction detection analysis and recording system to identify errors throughout the aircraft. The C-5 features a cargo compartment 121 ft long, 13.5 ft high, and 19 ft wide, or just over 31,000 ft. The compartment can accommodate up to 36 463L master pallets or a mix of palletized cargo and vehicles. The cargo hold of the C-5 is a foot longer than the entire length of the first powered flight by the Wright brothers at Kitty Hawk. The nose and aft doors open the full width and height of the cargo compartment to permit faster and easier loading. Ramps are full width at each end for loading double rows of vehicles. The Galaxy is capable of carrying nearly every type of the Army's combat equipment, including bulky items such as the 74 short tons armored vehicle launched bridge, from the United States to any location on the globe. A C-5 is capable of transporting up to 6 Boeing AH-64 Apaches or 5 Bradley fighting vehicles. Operational history. The first C-5A was delivered to the USAF on December 17, 1969. Wings were built up in the early 1970s at Altus AFB, Oklahoma; Charleston AFB, South Carolina; Dover AFB, Delaware; and Travis AFB, California. The C-5's first mission was on July 9, 1970, in Southeast Asia during the Vietnam War. C-5s were used to transport equipment and troops, including Army tanks and even some small aircraft, throughout the later years of the U.S. action in Vietnam. In the final weeks of the war, prior to the fall of Saigon, several C-5s were involved in evacuation efforts. During one such mission, a C-5A crashed while transporting a large number of orphans. C-5s have also been used to deliver support and reinforce various U.S. allies over the years. During the Yom Kippur War in 1973, multiple C-5s and C-141 Starlifters delivered critical supplies of ammunition, replacement weaponry and other forms of aid to Israel. The U.S. effort was named as Operation Nickel Grass. The C-5 Galaxy's performance in Israel was such that the Pentagon began to consider further purchases. The C-5 was regularly made available to support American allies, such as the British-led Peacekeeper Initiative in Zimbabwe in 1979. On October 24, 1974, the Space and Missile Systems Organization successfully conducted an air-mobile feasibility test where a C-5A Galaxy aircraft airdropped an 86,000 lb Minuteman ICBM from 20,000 ft over the Pacific Ocean. The missile descended to 8,000 ft before its rocket engine fired. The 10-second engine burn carried the missile to 20,000 ft again before it dropped into the ocean. The test proved the feasibility of launching an intercontinental ballistic missile from the air. Operational deployment was discarded due to engineering and security difficulties, though the capability was used as a negotiating point in the strategic arms limitation talks. Aircraft 69-0014-014 used in the test was retired to the Air Mobility Command Museum at Dover Air Force Base. The C-5 has been used for several unusual functions. During the development of the secretive stealth fighter, the Lockheed F-117 Nighthawk, Galaxies were often used to carry partly disassembled aircraft, leaving no exterior signs as to their cargo. It remains the largest aircraft to ever operate in the Antarctic. Williams Field near McMurdo Station is capable of handling C-5 aircraft, the first of which landed there in 1989. The C-5 Galaxy was a major supply asset in the international coalition operations in 1990-91 against Iraq in the Gulf War. C-5s have routinely delivered relief aid and humanitarian supplies to areas afflicted with natural disasters or crisis. Multiple flights were made over Rwanda in 1994. The wings on the C-5s were replaced during the 1980s to restore full design capability. The USAF took delivery of the first C-5B on December 28, 1985 and the final one in April 1989. The reliability of the C-5 fleet has been a continued issue throughout its lifetime, however the C-5M upgrade program seeks in part to address this issue. Their strategic airlift capacity has been a key logistical component of U.S. military operations in Afghanistan and Iraq. Following an incident during Operation Iraqi Freedom where one C-5 was damaged by a projectile, the installation of defensive systems has become a stated priority. The C-5AMP and ERP modernization programs plan to raise mission-capable rate to a minimum goal of 75%. Over the next 40 years, the U.S. Air Force estimates the C-5M will save over $20 billion. The first C-5M conversion was completed on May 16, 2006. C-5 milliseconds began test flights at Dobbins Air Reserve Base in June 2006. The USAF decided to convert remaining C-5BS and C-5CS into C-5 milliseconds with avionics upgrades and re-engining in February 2008. The C-5s will receive only the avionics upgrades. In response to Air Force motions towards the retirement of the C-5 Galaxy, Congress implemented legislation that placed set limits upon retirement plans for C-5A models in 2003. As of November 2013, 45 C-5s have been retired. 11 have been scrapped, parts of one are now a cargo load trainer at Lackland AFB, Texas and one was sent to the Warner Robins Air Logistics Center for tear-down and inspection to evaluate structural integrity and estimate the remaining life of the fleet. The U.S. Air Force began to receive refitted C-5M aircraft in December 2008. Full production of C-5 milliseconds began in the summer of 2009. In 2009, the congressional ban on the retirement of C-5s was overturned. The Air Force seeks to retire one C-5A for each 10 new C-17s ordered. In October 2011, the 445th Airlift Wing based at Wright-Patterson Air Force Base retired or reassigned all of its remaining C-5s. It has since re-equipped with C-17s. 16 C-5M aircraft have been delivered as of December 2013. The C-5 milliseconds have been delivered late from the production schedule due to unspecified complications. On September 13, 2009, a C-5M set 41 new records. Flight data was submitted to the National Aeronautic Association for formal recognition. The C-5M had carried a payload of 176,610 lb to over 41,100 aft in 23 minutes, 59 seconds. Additionally, 33 time-to-climb records at various payload classes were set, and the world record for greatest payload to 6,562 aft was broken. The aircraft was in the category of 551,160 to 661,390 lb with a takeoff weight of 649,680 lb including payload, fuel, and other equipment. Variants, C-5A. The C-5A is the original version of the C-5. From 1969 to 1973, 81 C-5s were delivered to U.S. Air Force bases. Due to cracks found in the wings in the mid-1970s, the cargo weight was restricted. To restore the C-5's full capability, the wing structure was redesigned. A program to install new strengthened wings on 77 C-5s was conducted from 1981 to 1987. The redesigned wing made use of a new aluminum alloy that did not exist during the original production. C-5B. The C-5B is an improved version of the C-5A. It incorporated all modifications and improvements made to the C-5A with improved wings, simplified landing gear, upgraded TF-39GE-1C turbofan engines and updated avionics. From 1986 to 1989, 50 of the new variant were delivered to the U.S. Air Force. C-5C. The C-5C is a specially modified variant for transporting large cargo. Two C-5s were modified to have a larger internal cargo capacity to accommodate large payloads, such as satellites. The major modifications were the removal of the rear passenger compartment floor, splitting the rear cargo door in the middle, and installing a new movable aft bulkhead further to the rear. The official C-5 technical manual refers to the version as C-5A, SCM, Space Cargo Modification. Modifications also included adding a second inlet for ground power, which can feed any power-dependent equipment that may form part of the cargo. The two C-5Cs are operated by U.S. Air Force crews for NASA, and are stationed at Travis AFB, California. 68-0216 completed the avionics modernization program in January 2007. 68-213 is currently being upgraded to the M modification. C-5AMP and C-5M Super Galaxy. Following a study showing 80% of the C-5 airframe service life remaining, AMC began an aggressive program to modernize all remaining C-5BS and C-5CS and many of the C-5As. The C-5 avionics modernization program began in 1998 and includes upgrading avionics to global air traffic management compliance, improving communications, new flat-panel displays, improving navigation and safety equipment, and installing a new autopilot system. The first flight of a C-5 with AMP occurred on December 21, 2002. The reliability enhancement and re-engineering program began in 2006. It includes new General Electric F-138GE100 engines, pylons and auxiliary power units, upgrades to aircraft skin and frame, landing gear, cockpit and pressurization systems. The CF-6 engine produces 22% more thrust from each engine, providing a 30% shorter takeoff, a 38% higher climb rate to initial altitude, an increased cargo load and a longer range. Upgraded C-5s are designated C-5M Super Galaxy. The C-5M reached initial operating capability on February 24, 2014 with 16 aircraft delivered. L-500. Lockheed also planned a civilian version of the C-5 Galaxy, the L-500, the company designation also used for the C-5 itself. Both passenger and cargo versions of the L-500 were designed. The all-passenger version would have been able to carry up to 1,000 travelers, while the all-cargo version was predicted to be able to carry typical C-5 volume for as little as 2 cents per ton-mile. Although some interest was expressed by carriers, no orders were placed for either L-500 version, due to operational costs caused by low fuel efficiency, a significant concern for a profit-making carrier. Even before the oil crisis of the 1970s, keen competition from Boeing's 747, and high costs incurred by Lockheed in developing the C-5 and later, the L-1011, which led to the governmental rescue of the company. C-5 shuttle carrier. Lockheed proposed a twin-body C-5 as a shuttle carrier to counter the Conroy Virtus, but the design was turned down. Operators. The C-5 is limited to military and government use. The U.S. Air Force has 71 C-5s in service as of February 2014 and plans to reduce the fleet to 52 M models by 2017. Military Airlift Command Air Mobility Command, 60th Military Airlift Wing Air Mobility Wing, Travis Air Force Base, California. 21st Airlift Squadron 1993-2006 22nd Military Airlift Squadron 1972-75th Military Airlift Squadron, 1970-92. 436th Military Airlift Wing, Dover Air Force Base, Delaware. 3D Military Airlift Squadron 1973-2007 9th Military Airlift Squadron 1971 31st Military Airlift Squadron 1989-94. 437th Military Airlift Wing, Charleston Air Force Base, South Carolina. 3D Military Airlift Squadron 1970-73. 443d Military Airlift Wing, Altus Air Force Base, Oklahoma. 56th Military Airlift Squadron 1969-92. Air Education and Training Command, 97th Air Mobility Wing, Altus Air Force Base, Oklahoma. 56th Airlift Squadron 1992-2007. Air Force Reserve, 349th Military Airlift Wing Air Mobility Wing, Associate, Travis Air Force Base, California. 301st Military Airlift Squadron 1973-2006, 312th Military Airlift Squadron 1973. 433d Military Airlift Wing, Kelly Lackland Air Force Base, Texas. 68th Military Airlift Squadron 1985-356th Airlift Squadron 2007. 439th Military Airlift Wing, Westover Air Reserve Base, Massachusetts. 337th Military Airlift Squadron 1987. 445th Airlift Wing, Wright-Patterson Air Force Base, Ohio. 89th Airlift Squadron 2006-12. 512th Military Airlift Wing, Associate, Dover Air Force Base, Delaware. 326th Military Airlift Squadron 1973-2007, 709th Military Airlift Squadron 1973. Air National Guard, 105th Military Airlift Group Airlift Wing, Stewart Air National Guard Base, New York. 137th Military Airlift Squadron 1985-2012. 164th Airlift Wing, Memphis, Tennessee. 155th Airlift Squadron 2004-13. 167th Airlift Wing, Martinsburg, West Virginia. 167th Airlift Squadron 2006. USAF operates two C-5CS for NASA, based at Travis AFB. Incidents and accidents. There have been 5 C-5 Galaxy aircraft lost in crashes along with 2 Class A losses resulting from ground fire and 1 loss resulting from damage sustained on the ground, with a combined total of 169 fatalities. There have been at least 2 other C-5 crashes that resulted in major airframe damage, but the aircraft were repaired and returned to service. Notable accidents: on May 27, 1970, C-5A serial number 67-0172 was destroyed during a ground fire at Palmdale, California after an air turbine motor started backwards and quickly overheated, setting the hydraulic system on fire and quickly consuming the aircraft. The engines were not running at the time of the fire. 5 crew escaped, but 7 firefighters suffered minor injuries fighting the blaze. On October 17, 1970, C-5ASN 66-8303 was destroyed during a ground fire at Marietta, Georgia. The fire started during maintenance in one of the aircraft's 12 fuel cells. 1 worker was killed and another injured. This was the first C-5 aircraft produced. On September 27, 1974, C-5A 68-0227 crashed after overrunning the runway at Clinton, Oklahoma Municipal Airport during an emergency landing following a serious landing gear fire. The crew mistakenly aligned the aircraft for the visual approach into the wrong airport, landing at Clinton Municipal Airport, which has a 4,400 aft runway instead of the airfield at Clinton Sherman Industrial Airpark, which has a 13,500 aft runway. This was the first operational loss of a C-5 Galaxy. On April 4, 1975, C-5A 68-0218 crashed while carrying orphans out of Vietnam during Operation Baby Lift. This crash is one of the most well-known C-5 accidents to date. The crash occurred while trying to make an emergency landing at Tan Son Nhut Air Base Saigon, following a rear pressure door lock failure in flight. 144 people were killed out of the 313 aboard. Use of the C-5 was heavily restricted for several months due to this high-profile accident. On July 31, 1983, C-5A 70-0446 crashed on landing at Shemya, Alaska. The C-5 approached below the glide slope, hit an embankment short of the runway and bounced back into the air before coming to rest on the runway. Structural damage was extensive and the 2 aft main landing gear bogies were sheared from the aircraft. There were no fatalities. A joint USAF Lockheed team made repairs enabling a one-time ferry flight from Shemya to the Lockheed plant in Marietta, Georgia. There, the aircraft was quickly christened Phoenix 2 and permanent repair efforts got underway. In addition to the structural repairs, Phoenix 2 also received an improved landing gear system, wing modification, and a color weather radar upgrade. The aircraft was returned to service. In July 1985, C-5A 68-0216 landed wheels up at Travis Air Force Base, California. There were no injuries. The accident occurred while the crew was performing touch-and-go landings, and did not lower the landing gear during the final approach of the day. The aircraft received significant damage to the lower fuselage and main landing gear pods. The C-5A was later flown to Marietta for repairs. While there, the aircraft was selected to be the first C-5A converted to the C-5C configuration. On August 29, 1990, C-5A 68-0228 crashed following an engine failure shortly after takeoff. The aircraft took off from Ramstein Air Base in Germany in support of Operation Desert Shield. It was flown by a 9-member reserve crew from the 68th Airlift Squadron, 433rd Airlift Wing based at Kelly AFB, Texas. As the aircraft started to climb off the runway, one of the thrust reversers suddenly deployed. This resulted in loss of control of the aircraft and the subsequent crash. Of the 17 people on board, only 4 survived the crash. All 4 were in the rear troop compartment. The sole crew member to survive, Staff Sergeant Lorenzo Galvan, Jr., was awarded the Airman's Medal for his actions in evacuating the survivors from the wreckage. On April 3, 2006, C-5B 84-0059 crashed following a cockpit indication that a thrust reverser was not locked. the C-5B assigned to the 436th Airlift Wing and flown by a reserve crew from the 709th Airlift Squadron, 512th Airlift Wing crashed about 2,000 ft short of the runway while attempting a heavyweight emergency landing at Dover Air Force Base, Delaware. The aircraft had taken off from Dover 21 minutes earlier and reported an in-flight emergency 10 minutes into the flight. All 17 people aboard survived, but 2 received serious injuries. The Air Force's Accident Investigation Board report concluded the cause to be human error, most notably the crew had been manipulating the throttle of the No. 2 engine as if it was still running while keeping the No. 3 engine at idle. The situation was further worsened by the crew's decision to use a high flap setting that increased drag beyond normal 2-engine capabilities. The aircraft was one of the first to receive the new avionics and glass flight displays for C-5 avionics modernization program. This accident led to a redesign of the cockpit engine displays, particularly the visual indicators of a non-active engine. The aircraft was a complete hull loss and the airframe scrapped, but the forward fuselage became a C-5 AMP test bed. Specifications. Data from Quest for Performance, International Directory of Military Aircraft, and USAF Fact Sheet, General Characteristics, Crew, 7 Typical, 4 Minimum, Payload, 270,000 lb, Length, 247 FTA 10 in, Wingspan, 222 FTA 9 in, Height, 65 FTA 10 in, Wing Area, 6,200 FT2, Empty Weight, 380,000 lb, Loaded Weight, 769,000 lb, Max Takeoff Weight, 840,000 lb, Power Plant, FORA, General Electric TF39GE. -1 high bypass turbofan, 43,000 pound force each, Performance, Maximum Speed, Mach 0.79, Cruise Speed, Mach 0.77, Range, 2,400 mi with a 263,200 lb payload, Service Ceiling, 35,700 ft at 615,000 lb gross weight, Rate of Climb, 1,800 a foot per minute, Wing Loading, 120 a pound per foot 2, Thrust Weight, 0.22, Takeoff Roll, 8,400 ft. Landing Roll, 3,600 ft. Fuel Capacity, 51,150 a USAF gal, see also. Aircraft of comparable role, configuration and era, Airbus A380, Antonov 124, Antonov 225 rear, Boeing C-17 Globemaster 3, Boeing 747, related lists, List of active United States military aircraft, List of Lockheed aircraft, references, notes. Citations. Bibliography. External links, C-5AC Galaxy and C-5M Super Galaxy U.S. Air Force Fact Sheet, C-5M page on LockheedMartin.com, C-5 Galaxy page on globalsecurity.org, fatigue and related human factors in the near crash of a large military aircraft. Aviation, Space, and Environmental Medicine, Volume 77, No. 9, September 2006, ppA 963 €970.